So So today our class is about what? About how to find what the intercepts of functions. So if we have this function, so this is f of x. The points where f of x meets the x-axis, these points, the x values at which f of x meet x-axis are called what? X-intercepts. These points are called x-intercepts. Now, what about the points where f meets the y-axis, like this point, this one? The point where the function f of x meets the y-axis is called what? Is called y-intercept. Okay, so how to find these intercepts? So I know that these points are the intercept, but I have an equation y equals to f of x. How to find the intercept, the x-intercepts, using what? Using this equation. How to do that? You should remember what is the equation for what? For x-axis. X-axis is what? Is the set of points where what? Any point of the x-axis, y has to be what? Has to be 0. So x is the set of all points where y equals to 0. So if you see at this point is what? Should satisfy the equation of the function. So y equals to f of x, but y must be what? Must be 0. So what we conclude? We conclude at these points, f of x must be 0. Okay, so for x-intercept, we have to solve this equation, f of x equals to 0. So x-intercept are the set of solutions of f of x equal to 0. So how to find y-intercept? You have to remember what is the equation of y-axis. Y-axis Any point on y-axis must meet what? X equal to 0. This point is 0, 1. This is 0, 2, 0, 3, 0, 4. So all the time, what? X is what? Is 0. So at this point, the same. X equals 0, y equals to f of x. At this point, x equals 0, but also y equals to f of x. Two curves meet at what? At this point. Y-axis and this curve. So x equals 0 and y equals to f of x. Now substitute the first equation into the second equation. What will happen? You just what? Find f of 0. X equal to 0, right? Substitute it into this equation. So replace x with what? With 0, right? So you have to find what? To find f of 0. So if you want to find the x-intercepts, you have to solve f of x equals to 0. If you want to find the y-intercept, just find f of 0. And that's it. By the way, x-intercepts, you can have one intercept, no intercept, of course. Some functions, they do not have an x-intercept. You might have what? One intercept, two intercept, three intercept, maybe 100 intercepts. But for y-intercepts, we have what? Only one intercept, only, which is what? F of 0. Since f is a function, 0 should be mapped into what? Into one value only, right? So we have one y-intercept, right?
Right.
Okay, so let us have an example. So say we have this function. This is x, y. So assume this is the curve y equals to f of x. What are the x-intercepts for f of x, and what is the y-intercept for this function? The x. Intercepts. Why? Because we have more than one, right? Are what? Minus 2. Yes, exactly. Minus 2, minus 1, and 2. Mhm. Now, what about y-intercept? Is? Thank you. So take up the list. So minus 1. Minus 1. So this is how to get the intercepts out of what? Out of a graph of what? Of f of x. What if we have what? A rule of f of x, not a graph of f of x. Say we would like to what? To know what are the intercepts of x squared minus 4. What I have to do right first to find which one is simpler, which one is easier, the y-intercept or x-intercept?
X.
No, y-intercept is much easier. Just plug in what? X equals 0. That's it. So the y-intercept is what? Y-intercept is f of what? F of 0. Just substitute x, replace each x with what? With 0. 0 squared minus 4. 0 squared minus 4. 0 squared, 0 times 0 minus 4 minus 4. X-intercept or intercepts find x-intercepts.
Y is always 0. Y always 0.
Which one? Y-intercept?
Yes.
You have to replace x with 0.
All the time 0.
All the time. Y-intercept is f of 0.
Okay.
To find x-intercepts, you have to solve f of x equal to 0. You have to solve f of x equals to 0. So just replace f of x with 0. 0 equals to x squared minus 4. And you can solve this equation using your calculator, using your factorization, using any solution you would like to use. Multiply 3 in your calculator will give us the final answer. There are two solutions. Multiply 3 2 and two solutions.
C is 0. C.
B is 0.
B, okay.
So 1, 0, and minus 4. 2 and minus 2. 2 and minus 2. X-intercepts are plus minus 2. Or simply, you can, this equation is easy to solve. Just move this 4 to this side. X squared is 4.
Square root.
X is square root of 4, right? But we said in the previous meeting, for square roots, you have to add what? Plus or minus, right? Therefore, the final answer is what? Plus or minus 2.
Stop when you take a picture.
Hmm?
When you take it.
Okay. It's recorded. Okay, now how about this one? 3 minus absolute value of x. How to find the x-intercept and the y-intercept. So starting with the easier intercept, the y-intercept. The y-intercept, by the way, let me go back. This function you will learn how to sketch this graph after like a meeting or 2 meetings. You'll be able to sketch this graph. If you sketch this graph, will be something like this. And this result coincides with the conclusion that the function has has two intercepts at -2, 2, and the y-intercept is -4.
طب is this parabola?
Yes, parabola. It's a parabola. So one of the elementary functions that you have to be able to sketch is the what? X squared. You will learn how to sketch these graphs. So going back to the absolute value, also absolute value is one of the elementary functions that you have to deal with in this course. So before graphing these functions, we would like to know what the intercepts for such a function. First, let us start with the easier intercept, with the y-intercept. So how to find the y-intercept in this case? Y-intercept is g of what? Of 0. Okay, so just replace x with 0. So 3 minus the absolute value of 0. What's the absolute value? No. What's the absolute value of 0?
0.
0. Absolute value of positive number or 0, it's 0. Absolute value of negative number, you have to multiply it by what? By minus. So absolute value of 0 is also 0. So 3 minus 0 is
3.
3. So this is the y-intercept. It means that this function will meet the y-axis at 3. Okay, so if I sketch, if I start to sketch this graph, I would start with what? With the y-intercept, 1, 2, 3. Okay. Now we find what x-intercept.
0.
You have to solve g of x equal to 0. So replace g of x with 0. Replace g of x with 0. 0 equals to 3 minus x. That's the value of it.
23.
And you have to solve this equation. You have two solutions. How to do that? Also, we learned how to do the absolute value last time. So move this absolute value to the side, or 3 to the side, as you wish. So move this absolute value to this side, absolute value of x equals to 3. How to solve an equation with absolute value? Just remove the parallel lines, but add what? Plus or minus.
Yep.
So when you solve a equals to plus, when you solve absolute value of a equals to b, and you want to get rid of these, just add plus or minus to the right hand side.
Absolute mean positive and negative of the number.
Yes. Just add plus minus to the what? To the right hand side, provided there's a condition. B must be greater or equal to 0, not negative number. Absolute value doesn't take what? Negative numbers. If I'm solving, for example, absolute value of x equals to -3, there's no solution. Talking about 0 or what? Or positive number. So absolute value of x equals to positive number. So now I can solve this equation. Absolute value of x, just take these out. X will be what? Plus or minus what? 3. So I know this function has two intercepts. One at 3, the other one at -3. Actually, the graph, you see that in the future, يصير تقال 3 minus تصير تقال x looking like this. At this moment you don't have to sketch, but after like a meeting or two, you have to start to sketch these functions. Okay. Take 2 minutes or 3 minutes to solve this on your own. Sometimes these assignments will be graded, by the way. I have 3 assignments in a class. So I can ask you to solve a question and grade it. So this is why, all of you should show up in the class. If I assign assignments in a class and you miss that class, you get 0. You get a pencil. answers?
I'll let them know.
So actual 0 is what? Actual 0. 2 minus radical of 0, right?
Yep.
Okay. 2 minus radical 0, 2 minus 0, which is 2. So this is the y-intercept. What about the x? What about the x-intercept?
Forward.
Well, about the x-intercept, but y-intercept.
Only
Plug in.
zero.
Right. Yes, but don't put plus or minus. This is radical squared.
You told us.
That's removing x squared. Huh? X squared equals to 4, then x is a plus or minus 2. X squared, not radical.
Okay.
So let us solve the question. Y-intercept. Y-intercept is h of 0. H of 0, just plug in x, replace x with 0. 2 minus radical of 0. Using your calculator. Yes, 2. So this function intersect the y-axis at 2. Now x-intercept,
Forward.
just replace h of x with 0. So 0 equals to 2 minus radical x. Move this to this side. So x, you want to get rid of what? Of this radical. So square both sides. Okay,
Then will be x equals.
x to the power 1/2 squared. Squared with 1/2.
Coordinating this one.
Yes.
And then
2 squared is 4. Not plus or minus 4. Only 4. Plus or minus goes with what? With if we have an even power. To a number. To a number. You have to what? If you take the even the root with this power, you have to add plus or minus. And this function, you'll know how to sketch this graph. It will be something like this. You will know how to do that after 2-3 meetings. This function will look like this. So this one I know, this is 4, and this is 2. So this is a similar exercise. All right, now talking about what? Talking about domain of functions. How to find domain of functions. So let us take a function f of x divided by x minus 2. And I ask you to fill this table. X, f of x, minus 1, 0, 2, 3. I want f of x at these values of x. I want f of x at these values of x.
The first one.
First
over
one,
3. 1 over 3.
minus 1, right? Divided by minus 1, minus 3, minus 2, I'm sorry.
Minus
So 1 over 3.
Second one is 0.
At 0, 0. 0 over 0 minus 2, 0 over minus 2, 0. What about 2?
0 over 2. 0 over minus 2.
At 2.
will be error.
Not
2
0,
over
not
0.
right? We forgot the parentheses.
But
So 2
Over 0.
over 2 minus 2. If you use your calculator, don't forget the parentheses. So 2 over 0. 2 over 0, there's no such thing in math. You cannot divide by 0. So this is math error. Or what? Or does not exist.
No solution.
error.
Does not exist. What about 3? 3 over 3 minus 2. 3 over 1. 3 over 1, 3. So what I get out of this, f of minus 1 is a real number. F of 0 is also a real number. F of 3 is a real number. But f of 2 is not a real number. Does not belong to the what? To the real numbers. What I should say in this case, I should say that 2 is out of the domain. It's out of what? Out of the domain. Domain, if you want to define what's the domain of any function f of x, it's all x such that f of x is real number. In other words, all the value of x such that the image exists. The image exists. Okay. I have a question also about this function. So what is the domain of this function? Which of the values out of the real numbers should I exclude from what? From the domain of this function?
Minus 2.
Not minus 2. So it's in there.
Yes, 2.
Which value? 2. Only 2? Yes, only 2. Why? You see, what caused this mess? What caused this mess? It caused because 2 is the 0 of the denominator. Do we have any other zeros for the denominator? No. Solve this. X minus 2 equals to 0. Solve this equation. X equals to what?
2.
To 2. At 2, we will have a problem with what? With the denominator. Therefore, the domain of this function is all real number except for what? For 2. So if you use D for the domain, you would write what? All the real number except, so exclude what? 2. This is acceptable notation. You may write also the real numbers except for 2. Also, this is acceptable. Okay. Maybe a third one will say an interval from -infinity to 2, and from 2 to infinity. Also, this is accepted. Why? Because you see, you excluded 2. All the real numbers, but we took 2 out of the real numbers. Okay, so this is the first issue. The first issue, if we have a denominator equals to 0. Let us concentrate on this point. So let us take functions with the numerator and denominator and find the domain of these functions. Let's take f of x to be x squared minus 4, 2x. Let's take f of x equals to 2x over x squared plus 4. F of x equals to 7 divided by 2 minus absolute value of x plus 1. D f of x equals to 5 minus radical of x minus, I'm sorry, not going to, I don't want to deal with radical yet. So this is enough.
Sir, what numbers we use for x? They can be any number?
All of the real numbers.
Except 0.
But we said at the last remark was what? If you have fractions, you have to look to the zeros of the denominator and exclude it from what? From the real numbers. Okay, so put the denominator equals to 0 and exclude it out of what? After the real numbers. This is the domain. The table is to check your answer. I'm not going to use the tables anymore. If you have a fraction, you would think about what, concentrate on what? The denominator. Find the zeros of what? Of the denominator. Then exclude it out of what? Out of the real numbers.
So we make the denominator equal to 0?
Yes, exactly. So first one, what I have to do, just solve what? Solve x squared minus 4 equals to 0. Just set this equals to 0. X. So this is the solution of A. X squared minus 4 equals to 0. If there is any solution, you have to exclude it out to the real numbers. If none, real numbers, the whole real numbers. So solve this equation.
Equal to 2.
Not 3 mod 3 1 or you have to or you solve it manually. X squared equals to 4. X equals to what?
2.
Plus or minus 2. Just start it. X to the power even equals to a number. You have to put plus or minus. So the domain of this function is all real numbers except these numbers. Okay? All real numbers except what? So the domain of f of x includes all the real numbers except what? Plus minus what? 2. Of course, I want to write this in math notation. All real numbers means this R except plus or minus, so I have to exclude plus or minus 2. In set parentheses, of course. In set brackets. So this is the domain of this of A. All right, what about the second one? The second one, I just made a slight modification to the numerator. Do you think that we have the same result or?
The same.
Mhm.
Just here we have plus, there we go minus.
So we're solving x squared plus 4 equals to 0. X squared equals to minus 4, right? X squared equals to plus or minus radical of minus 4. So what's the final answer?
So
So solving this equation equals to
Minus
0.
2 will be.
Okay? equals to 0. X
Minus
squared equals to minus 4. Therefore, X is plus or minus radical of minus 4.
Will be minus 2.
Use your calculator. What's the radical of minus 4?
2i.
So this is you change the mode into complex numbers, right?
ما في
I'm talking about real numbers.
Will be math error.
Math error, right?
Doesn't.
There's no such value.
Sir, how do I change it?
Yes. Radical minus 5.
Okay.
Chapter 5 will deal with complex numbers, but right now we're dealing with real numbers only. So there's no such thing. No solution. So what's the domain of this function?
Real number.
All of the real numbers. Yes, you're right. We're not going to exclude anything out of what after real number, right? So the domain is all of the real numbers. Okay, if you finish, writing part B, go to part C. Try to solve the last part.
Instead we will solve it in different way, not the same way.
It's looking like the first part, but you have to deal with this absolute value.
There is no D. Sir,
What do you mean by there's no D?
the question D. You cancel it?
Yes, there's no part D.
I thought so will be minus 3.
Two values. You're asking about
C.
part C?
Yeah.
Two values. You have to exclude two values.
First will be minus 2.
We'll see.
Not real number.
Any answers?
First one will be -2.
I got plus -1.
Okay, you say -2, right? Substitute in the denominator. -2 plus 1, -1, right? Absolute value of -1 is 1. 2 minus 1, it's okay. The denominator is not 0. So we have to get values for which the denominator equals to 0. So that's Abdullah saying plus minus 1. Let's check his answer.
Also me, sir.
1 plus 1 is 2. 2 minus 2, 0. Yes. What about minus 1? Minus 1 plus 1, 0. 2 minus 0? No. Minus 1 is not, it's not a solution. So let us see the exact solution of this. So let me erase and solve this. 7 divided by 2 minus 7 divided by 2 minus absolute value of x plus 1. We're looking for the domain of this function. So you have to solve the denominator equals to 0. Move this to the side to be positive, right?
Yes.
Equals to 2. So we have absolute value of x plus 1 equals to 2. As I said, if absolute value of x equals to a positive number or 0, just what? Take it out, and we have to replace it by what?
2.
Plus or minus 2. So you have two equations. I mean, you solve x plus 1 equals to 2. X plus 1 equals to 2, or x plus 1 equals to what? Minus 2. You can solve these equations easily. Just move 1 to the side. 2 minus 1 is 1. Move this one to the side, minus 1. So x will be what?
Will be
Minus 3. So these values are out of the domain.
real number.
These are out of domain. Let us check our answer. Substitute x equal 1. 1 plus 1,
2.
2. Absolute value of 2 is 2.
Yes.
2 minus 2,
0.
0. We're dividing by 0. Just check minus 3. Minus 3 plus 2,
Plus 1.
minus 2.
Minus 2.
Minus
Absolute value of minus 2 is 2. Minus 2,
0.
0. So we're dividing by 0. Okay, so what is the final answer for the domain? The domain is the whole real numbers, except for what? For 1 and minus 3. Or you can write something like this. It's up to you. You mean this notation or this one? Both are accepted. All right, the second case, so we treated the case with what? With denominator, right? Now the second case, which will restrict the domain or will chop part of the real numbers, is what? When we have radical. When we have what? Radical. So let me start with the same procedure. Let us take f of x equals to radical of 2x minus 4. Let us fill this table.
So now it is not fraction, so we cannot make equal 0.
It's not a fraction. It's radical. So the first issue in math, I cannot divide by 0. This is the first issue. I cannot do this. Divide it by 0. This is, you cannot do that in math. Okay? This is the first alert. You cannot divide by 0.
Radical 2.
Okay, this one, 2
Radical
times 3, 6, minus 4, 2, radical 2. And you can find it easily using a calculator in decimal way. In decimal representation.
أستاذ
Yes.
جذر يعني راديكال.
And 2 times 2, 4. Minus 4, 0. Radical of 0, your calculator will give you what? 0, right? So no issue.
Zero.
So these numbers are what? Are real numbers. Therefore, 3 in the domain of this function. 2 is also in the domain of function. No? Yes. What about 1?
Zero.
2 times 1, 2. Minus 4, minus 2. Radical of minus 2. Radical of minus 2 does not exist.
Zero.
Does not exist.
Also the last one.
Huh?
Zero.
Does not exist means that 1 is not in the domain. Of f. Okay, so 1 out of the domain of this function. 0, 2 times 0, 0. Minus 4,
Minus 4.
minus 4. Radical of minus 4 also does not exist. The same conclusion about 1. So also 0 or x equal 1, x equals 0 is not in the domain of f of x. My question now, what is the domain of f of x? Okay, so I should exclude what? 1, 0, then minus 1, then minus 2, minus 3, minus 4, etc. Or what? Just excluding minus 1 and 0, that's it? Or we have other values should be excluded out of what? Out of the domain. So we reach the second alert. If you have radical, you cannot have negative inside it. So anything inside the radical must be greater or equal to what? To 0. Greater or equal to what? To 0. Okay, so what I should do, I should take this and set it as greater or equal to what? To 0.
But -4 is not greater than 1.
No, I'm saying I have to exclude 1 and 0, right? We'll see, do we have any other values in addition to 0 and 1 should be excluded from the domain? How to do that? Just set the expression inside the radical greater or equal to 0. Okay? Greater or equal to 0. I can deal with equal to 0, but how to deal with the greater or greater than? It's easy. It's the same like equal to. So solve equals to 0. So it's like the denominator. Set it equal to 0. Solve equals to 0. Then what? So solve this equation equals to 0. So let us forget for a second about what the greater than. Let us deal with what equals to. So 2x minus 4 equals to 0. Solve this equation.
-4 will be there.
2x
2x
equals to 4, x equals to 2.
Yes. We will
Okay.
divide.
Now go to the real number, real line, and you know the real line starts from minus infinity, right,
Opposite.
to positive infinity. Now the domain will be split at x equals 2. So you see this 2? Either the values to the right of 2 or to the left of 2 will be in the domain. The other one will not be in the domain. Okay? Now you are testing the sign of 2x minus 4. 2x minus 4. Okay? So let us see. What is the sign of 2x minus 4 at this, for these values? You give me a value which is less than 2, between minus infinity and 2. Minus 2. 0, 1. All of these values less than 2, right? So take, for example, x equals 0. Okay, substitute. 2 times 0,
0.
0. Minus 4,
Minus
minus 4. So the value will be negative. So radical of negative. Radical of negative out of the domain. Let us go to the right of 2. What do we have values to the right of 2?
4.
4. 2 times 4,
8.
8. Minus 4,
2. 6.
4. Positive. Right? So all of these values are what? Are positive. When you take radical for positive, it's all right. You can do that, right? So what's the domain of this function? The domain of this function, all the values to the right of 2. How to write it mathematically? This is interval from 2 to what? To infinity. So the domain here is 2. Why? It's included. 2 is good. The value f of 2 is what? 0. It exists.
So greater
To what?
than.
Comma? To where? From 2, starting from 2 to what?
plus infinity.
To plus infinity. And open. Why open? Plus or minus infinity, by the way, are not what? Are not real numbers. So you have to keep them what? Open. In big calculus, calculus 1, calculus 2, etc. Plus, minus infinity are not real numbers. When you deal with them as intervals, you have to keep the interval what? Open at these numbers. Okay, to solve another question. If you want to take a screenshot or write. Okay, let me take another example. And I want to find the domain of find the domain of f of x equals to radical 7 minus 3x. And I'm going to use the same form of for. The for, you will get something like this, multiple choice. Most of the time, this question is multiple choice. So this is the for assembly. So how to find the domain of this function? As I said, if you have 1 over quantity, you have to start with what? With solving this equals to 0. Okay? And make sure to pick the values for which the denominator is not equals to what? To 0. This is the domain. If you have radical of something, you have to solve this expression is greater or equals to 0. We have a third case, but we'll talk about it next time. When we have a combined case, we have denominator and radicals. We'll deal with it in the upcoming meeting. So how to find the domain of this function? Radical of any expression, this expression must be greater or equal to 0. So set this greater or equal to 0.
Maybe I think so, it will be C.
Let us check. So this is greater or equal to 0. 7 minus 3x is greater or equal to 0. So forget about the greater than. Let us what? Let us solve this. 7 minus 3x equals to 0. So this equation.
7 will be 4x.
3x goes to the side. 7 equals to 3x. X is 7 over 3, right?
Yeah.
So now the real number from minus infinity to infinity. Positive. And take the value 7 over 3. We're looking for the numbers which satisfy this inequality. Okay? So take a value which is to the right of 7 over 3. Take a value which is to the left of 7 over 3. To the left of 7 over 3, what do we have? A negative number, right? 0. 0 also on the right, on the left, all right? So substitute x equals 0. Let us check. 7 minus 3 times 0. Is it greater or equal to 0?
Yes, equal to 0.
3 times 0?
0.
0. 7 minus 0? 7, right? 7 greater or equal to 0. Correct or not?
Yes.
Yes. So, yes. What about to the right of 7 over 3? Give me a number which is greater than 7 over 3.
8 over.
8 over 3, or 9 over 3, which is 3. Right? So 3. Take x equals to 3. Substitute it in this equation. 3 times 3,
9.
9. 7 minus 9,
Minus 2.
minus 2. Minus 2 greater or equal to 0? No.
And,
So where's the domain? This is your domain. The domain
7 over 3.
from minus infinity into what?
7.
7 over 3.
Right.
From minus infinity to 7 over 3. So A is the domain. Okay, before going home, what if we have a function like this? X squared, x to the x squared plus 3x plus 2. What's the domain of this one? So we have two cases. If you have denominator, you have to solve the denominator does not equal to 0. If you have radical, you have to what to solve the expression inside the radical greater or equal to 0, right? What about this function? This function does not contain what? Does not contain a fraction, does not contain a radical.
So what is C?
What is C? From -2 to -1. Why?
Modify it.
Why are we solving equals to 0? Solving equals to 0, you need it when you deal with what? With, for example, if we have x squared plus 3x plus 2 in the denominator, you have to do that, right? Or if you have radical of x squared plus 3x plus 2, you have also to deal with this, right? But this function does not have a radical nor a fraction. So what's the domain in this case?
All real numbers.
Correct. Excellent. Yes, there's nothing to exclude. You exclude when what? When the function has what? Has a fraction or radical, right? This function does not have anything, right? So this function is nice function, which means yes. And you can check that. Take f of -5 exists. F of -4 exists. F of 0 exists. F of 1 exists. F of 100 exists. So the values f of any real value all the time what exist, which means the domain from -infinity to what? To infinity for r. This is the same, right? From -infinity to infinity. And this is the end of our class for today.